Sorry that it's 4 a.m. and I have a country and I'm a little bit sleepy. My presentation is about our paper. The title is Student Dari, a speech classifying deep neural networks. Recently, many researchers have focused on building and improving speech recognition systems to facilitate and enhance human-computer interaction. Today, automatic speech recognition system has become an important and common tool from games to translation systems, robots, and so on. However, there is still a need for research on speech recognition systems for low-resource languages. This article deals with the recognition of a separate word for Dari language using Mel-frequencies, cepstral coefficients, feature extraction method, and three different deep neural networks, including convolutional neural network, recurrent neural network, multilayer perceptron, and two hybrid models of CNN and RNN. We evaluated our model on our building isolated Dari words corpus that consists of 1,000 utterances for 20 short Dari terms. This study obtained the impressive result of 98.3% average accuracy. Maybe all of you know that automatic speech recognition tools have played a remarkable role in human-machine interaction since the advent of more advanced technologies and smartphones. Research on ASR for regional and many Asian languages such as Arabic, Urdu, or state of the art in recent decades. However, it faces many challenges such as different dialects and the lack of resources, for example, a data set with adequate terminology. Dari is one of the low-resourced language and an Asian language. It is the official language of Afghanistan, one of the official languages of Afghanistan, and is spoken as a first and second language by the majority of Afghan residents of about 32 million inhabitants. Only a handful of people are familiar with modern technology devices and applications. Hence, ASR can facilitate their interaction with machines like smartphones, because as you know, most of the people in Afghanistan are not literate, and they are illiterate. They cannot write, but they can speak. So ASR systems can facilitate their interaction with smart devices. The most key challenge in developing an ASR system for Dari is the lack of available datasets and the great variety of dialects. For instance, the Hazara dialect is very different from the Herat Residence dialects, and both vary in intonation with how Kabul natives speak. There are more than 100 dialects, different dialects in Dari language. Similarly, either the corpus is not for most NLP research purposes, or it does not have enough records or vocabulary. For example, in this research, we were trying to find any Dari corpuses to use, but we couldn't find. To the best of our knowledge, there is no published article considering the evaluation and comparison of the performance of different models on Dari ASR. The primary purpose of this article is to provide a more robust and less error-prone ASR system for Dari through developing Dari isolated words ASR using three different deep learning techniques, including multilayer perceptron, convolutional neural network, long short-term memory, a hybrid model of CNN and LSTM, and a hybrid model of CNN and bidirectional LSTM. Consequently, we compared the output of the different proposed models. This research is a novel in the field of Dari speech recognition that compares the efficiency of 5 state-of-the-art deep learning approaches. We used our previous building Dari corpus dataset or dataset, and in this collection there are 1,000 sounds, which is related to 20 short Dari terms. The speakers express the words in different dialects of Dari language. There were 20 Dari native speakers, both male and female categories. And the speakers recorded audios in their home and office in a noise-free environment. The utterances were recorded by a smartphone audio recorder tool. Then they were translated to the PC using a USB cable. We removed background information from speech signals and limited the length of each file to 1 second using Adobe Audition software. Finally, we saved all audio files with the .wav extension format. However, every word was saved in a separate file with its name. Subsequently, all utterances files related to a single term are located within the same folder. As an example, all audio recorded associated with the salam term from all speakers are stored in the Fold 20 folder. Consequently, there are 20 separate folders, each relevant to a single term. In the end, we obtained 1,000 utterances, and some of the files were correct. This study is one of the state-of-the-art research in the field of Dari ASR. The core building block of the proposed ASR system are audio signals that are input MFCC to extract feature from voice signals and 5 separate deep learning models to recognize utterances or sounds. Besides, we divided the data set to train and test sets with different ratios for evaluating the performance of architectures. Each method was trained and tested. Finally, the entire models are able to illustrate the detected term as output. This research uses MFCC, and that's the most dominant method for extracting key attributes. What was our models? One of our models was CNN. Our deep CNN model consists of 4 layers, each containing 2D convolutional layers, followed by max pooling layers, except for the last layer that uses global average pooling. Subsequently, it has a fully connected layer in the last as an output layer. Of the first convolutional layer is a 2-dimensional tensor of 40,174 representing MFCC features, which convolve with 16 convolutional kernels. The next convolutional kernel is convolved with 32 filters. We doubled the number of kernels in the subsequent layers. Each convolutional layer convolves with 2 filters. We use the linear activation function to overcome the gradient vanishing problem. We used ReLU, which is a well-known activation function in this study. Also, afterwards, we used max pooling to the feature to reduce the sampling of the feature map by dividing the feature map into a small rectangular area, usually called the window, which does not overlap each other. We use max pooling with the pool size of 2 instead of other pooling layers for the first 3 blocks. Max pooling selects the maximum unit, while average pooling chooses the average unit of entire units in a certain window. The performance of a model is affected by noise samples during training. Therefore, dropout is applied to prevent a neural network from our filters. The output size is the same as the total number of classes, which is 20 classes each related to a certain word. In MLP model, we used two hidden layers, ReLU activation function, we use the ReLU as the activation function, and every single layer except the output layer has 300 neurons. Also, we use that dropout of 2.0 to decrease the likelihood of forfeiting on training data by randomly excluding nodes from each cycle. The input shape for this model is a one-dimensional feature vector that contains 40 features, as each sample contains 40 MFCC features. The output layer contains 20 nodes, each representing a class, as followed by the softmax activation function, like our CNN model. In recurrent neural network, our RNN model is a sequential model that consists of one long short-term memory, LSTM, or architecture block with the size of 64, which is followed by a dropout. The LSTM model uses the turn function to activate the cell mode and the sigmoid activation function for the node output. The next layer is the flattened layer to collapse the spatial dimensions of the input into the channel dimension. The output of the flattened layer passes the output layer. The output layer consists of 20 nodes. Finally, the output layer is followed by the softmax activation function. In our hybrid model, we implemented two distinct hybrid models to evaluate the performance of deep learning techniques in our Dari SR system. The first model is composed of four two-dimensional convolutional hidden layers, followed by a single LSTM hidden layer. Additionally, it contains a fully connected layer and an output layer at the end. The second hybrid model is like the first one. However, we substitute the LSTM with the bidirectional LSTM technique and flatten the output of LSTM before feeding it into the output layer. Each hidden layer is followed by the ReLU activation function. Additionally, a 2D max pooling layer is associated after every convolutional 2D layer, like the deep CNN structure. The capacity of LSTM is 64 in both models. We manually fine-tune the number of layers, dropout rate, epochs, and batch size to reach the optimal value. As a result, 20% dropout is employed after a max pooling layer. For finding the results, we used threefold cross-validation to evaluate the performance of each model. In all the select models, we used the categorical cross-entropy as loss function, accuracy for the metrics, and ODM as the optimizer. Average accuracy and loss during training and testing for each model is represented in this table. The impressive average accuracy result 9.98% on training and 98.365% on testing data were achieved related to the CNN by LSTM model. This result shows that the hybrid combination of CNN and bi-LSTM model for the isolated word-speech recognition system outperforms than other models that we used in this study. This paper demonstrated the impact of 5 different deep neural network models along with sensible training techniques for recognizing one-word Dari speech. It extracts audio signal features using MFCC. According to this study, the CNN and hybrid CNN models performed better in the field of isolated ASR for Dari words. This is a commencement study on Dari natural language processing, and supplementary research needs to be done. The future work of this study is to implement continuous and more accurate Dari ASR models using hybrid models and novel techniques. However, a larger and richer set must be created for this purpose. This is a very basic research on the ASR, but we are starting the chapter of ASR in Dari language, and we will continue it and we will develop and using model techniques for this purpose. Thank you for your attention.